All right, so I have all my numbers typed in, and it wants me to use the calculator to write the line of best fit. And we did this in Algebra 2. So remember to do this, I'm going to get out of this screen altogether by hitting second quit. And then raise your hand if you remember where I go to for this. Or you want to take a guess. Brandon. Well, not graph, because I don't want to graph it yet. I just want to write the equation. Justin? Stat. We're going to click on stat. We're not going to go to stat plot yet, because we haven't written the line yet. And then you go over to calculate. And we are talking about a linear regression. We think that this is linear. So we're going to go down to linreg and click enter. Or you can type the number 4. It'll do that also. So my x's are in list 1. My y's are in list 2. And then the rest of this, do you guys have the store regression equation? Oh, perfect. Okay, go down to that one. And if I do this right, now I've not done this before, so this is interesting. We're going to click on the word vars. I have it highlighted up here. And then click over. And then you see how you have functions now? I'm going to click enter on functions. And on Y1, I'm going to click enter. And now I'll just go down to calculate and hit enter. So there's my equation. Y equals 0.95, I'm going to round that to 0.95, x plus 56.2. Go ahead and write that equation down. All right. So before we go any further, let's actually talk about what these numbers mean. Let's start with the y-intercept, 56.19. What does that mean? That is my y-intercept. What's that mean, though, according to my data? Sparta. 56.19 million when? When? Yeah, that's right. So in 1990, there were 56.19 million women in the workforce. Okay, we have to be able to understand what the y-intercept and x-intercept mean according to my problem. All right, now the tough part, the slope. 0.95. Now, slope is what over what? What? Rise over run. Rise is what letter? Y. So we know this is y over x. So I'm going to rewrite this. Y over x. Which one's my y? What? No? The women? Women. And my x is the years, right? And I'm going to rewrite this. 0.95 over, what can I put anything over? And it stays the same. 1. Okay. So now we're going to try to put this in words. Are you ready? For every 1 year, the amount of women increased by 0.95 million. So, for every 1 year, the amount of women increased by 0.95 million. Does everybody see how those numbers come out? Okay. On tonight's essential work, you actually have to find the equation of best fit, but then you have to be able to tell, what does that slope mean? And that's what it means in words. Does that make sense? 0.95. All right. So Justin wanted me to go to StatPlot to graph this, right? Because it does say down here, sketch a scatter plot with the line you found on it. And I could make you make a graph in your notebook, but we're going to skip that. Tonight's essential work, you have to make a graph. You can do one, right? Okay. But let's check out the calculator. calculator and see if we can do it that way. So Justin said, hey, I can probably do this through my stat plot. So let's go to that. Second, y equals. We're going to turn on plot 1. So we're going to hit enter. And I'm going to turn it on by clicking enter, and now the on is highlighted. Now, notice I've got several graphs. This first graph is a bunch of dots. I'm going to move this over. It's going to be a little easier than to see it. There we go. The first graph is all dots. The second graph actually connects the dots. And then these ones we'll talk about later. Okay, and same with this one. So which one do we want? The very first one, right? We don't want them connected. We just want the dots on there. Our X list is L1, our Y list is L2, and then you get to pick if you want boxes, pluses, or dots. And hit graph. No, it didn't show up. Why didn't it show up? My numbers are too big, right? Like 56,056,056. Wait, this only goes to 10. So the way you fix that is you click on zoom, and you go down to zoom stat. There we go. I didn't know where it was exactly on this calculator. That's why I was clicking down until I found it. Zoom stat, and I'll click enter. And there it is. Wait, the line of best fit there too. How did I get the line of best fit all of a sudden? How did I get that? What? Anybody know how I got the line of best fit to appear magically on there for me? Remember when you did that LinReg and I told you to click on vars, go over to function, you clicked on y1? You actually put that equation right into y1. It typed it right in for you. You did not have to type it. See how that lovely little thing does a lot for you, doesn't it? Well, remember when we ran our equation, stat, calc, we did LinReg, right? And then we did x, y, but remember here, store equation, I had you go to vars, over to y vars, to function, to y1. Okay? And you type that right in there. It then put it into y1. You didn't get that? Okay. All right. Does that make sense? So was that a good fit for this graph? Yeah, that looks pretty linear. It looks like most of those points are hit. So in this case, a linear function makes sense. Not always does it though. All right. So you pretty well remember this? Yeah, nothing's really new, right? Okay, let's go to our new stuff. We're going to talk about variation. The part you need to copy down is the top part only. So we're looking here at directly proportional. Okay? Now, they actually have to help us out in a word problem to tell us something is directly proportional. Either they can give us the word directly proportional, okay, or they can give me the word varies directly. Either way, when you see those two words, you should immediately write down this equation. Y equals KX. Okay? So that's the equation if it varies directly or varies proportional. Now here it's saying the interest is directly proportional. The interest is directly proportional. So interest is going to be which letter here? What? Y, right? So this is actually my interest, which is $187.50 equals K. What do you think X is? How about the 2,500? Right? Now use your calculator, figure out what K is. Now, K is a constant amount. And And what I mean by that is in this word problem, K will always be the same. In the next word problem, K will be the same for it. Okay? And Leanne, what'd you get for K? 0.075. That actually means it's 7.5% interest. Move your decimal over to that's 7.5%. Now, when something varies directly, you kind of need to be able to tell that not only from the word problem, but if I give you a table of values to figure out if it varies directly. Here's how you know. If the one thing's increasing, the other thing is also increasing. Or, if the one thing's decreasing, the other thing is also decreasing. Does that make sense? Okay.
While the earth actually the money
No.
while it will be open.
No. You've got to read the problem. See how right here it tells me the interest is directly proportional? Blank is directly proportional. I used that statement there and filled that in. That's how I did that. So I want you to come up in your group with one real life example of when something's directly proportional. So when something's increasing, something else is increasing. Okay, or when something's decreasing, something else is decreasing. A real life example. All right. So Cheyenne, you were actually just talking about the older a car is, the less money it's worth, and that is actually inverse variation. Okay. That brings us perfectly into that. So go ahead and take a minute and write that down. Okay. But the one I was thinking of for direct variation, the more gas you buy, the more you have to pay. I always think that when I go to the pump. Okay. Take a minute, copy down the first 3 lines. Okay, so here we're talking about inverse variation, and Cheyenne's already given us an example. The older a car, that's a larger number, the less it's worth, so that gets us the smaller value. So as we're reading, it says the demand for a product varies inversely. That's how I know I'm going to use an inverse variation. Okay, the demand. So demand varies inversely. K over, and as the price, right? So price is going to be that bottom number. Does everybody see how I filled in that equation just to help me out a little bit? Okay. So now I'm going to use my two numbers, the $2.75 and the 600. They go together. So the 600 equals K over $2.75. How do I figure out K? Whitney. Multiply the 275 and the... That's correct. Go ahead and multiply this. And Trevor, what do you get? So that's my K. But that's not my equation, right? It says write an equation. Are you ready to write the equation? D equals 1,650 over P. I changed Y to D. I changed X to P. Why did I do that? Not to confuse you. I promise that's not it. Nathan. Yeah, I used words from the problem. I narrowed it down a little bit, right? Okay, so now I want you to figure out the last line. It says approximate the demand at price of $3.25. So here's my equation. Figure out the demand if the price is $3.25. Whitney. 500 and what? 0.6? 0.69? Okay, so there's my demand. Does that make sense? All right. Come up with a real life example for this. So one thing's increasing, the other is decreasing. They go opposite ways here. Try to come up with another example for this. So here's our other one, direct variation as the nth power. It's our final one we're talking about. So the distance an object falls varies directly. So I know immediately I'm going to be using y equals kx, right? Uh-oh. But it says as the square of the duration. So instead of it just being a regular x, it's now going to be x. See the only difference between that and the direct variation? We had to throw a square on because it had the word squared. Does that make sense? But now let's change it so it uses letters from the problem. The distance an object falls. So instead of y, I'm going to use the letter c. K is always k. It's a constant. It has to be a k. As the square of the duration of the fall. When you think duration, what do you think? Time, right? So we'll use t. Y equals k t squared. So given the two things they give me, find k. So I'm going to fill in my numbers. D is 144 equals k times 3 squared. 3 squared, remember, is 9. What's 144 divided by 9? 16. Now, it does say write an equation relating the distance and time, so we've got to do that. K equals 16 is not an equation. It's not. Your equation is D equals 16 t squared. That's my equation. I fill back in the k, and that way, if I tell you time is 20 seconds, you can figure it out. If I tell you time is 30 seconds, you can figure it out. Wait, if I tell you time is 6 seconds, go ahead and figure out the distance is it falling. Go ahead, Justin, what'd you get? 530. I like that you said that. Sorry. Sorry, you just made me very excited there, Justin, because you said something very important. Feet. He labeled it feet. Right? Wait. So I plugged 6 into my equation. That's all I did. Okay? Does that make sense? Now, make sure when you're doing tonight's essential work, if it says write an equation, that's how you write an equation. By the way, anybody currently in physics or taking physics? Or you may have done this in your other science classes. You learned about gravity, and it falls at 16 feet per second squared, right? That's where 16 is from. So, homework. Notice I've underlined 4 problems, right? Those 4 you do not need a calculator for. How nice. The first 2 you do. So if you do not have a calculator at home, at the end of the day, you can come borrow one from me. Sound good?